Now let's continue with our standard visualizations, and in this lesson, we're going to focus on line and area charts. We'll be using the same Power BI file from the last lesson. Go ahead and click the plus sign to create a new page, then double-click the tab to rename it. We'll call this page Line and Area Chart. What we're going to do here is create some trending insights using these two visual types. First, let's grab a line chart from the visualizations pane. It's right here in the top left. I'll drag it onto the canvas and stretch it out a bit. For this example, we want to analyze profit. So I'll head to the orders table and find the total profit measure. Drag that into the values field. Right now, we're just seeing a single data point, the total profit, which isn't very helpful. To make this line chart meaningful, we need to define an x-axis. That means choosing a date field to determine the time granularity over which we want to track profit. Let's go up to our dim date table. Instead of using monthly data like we've done before, let's get a little more detailed and use start of week. I'll drag that into the axis field. We don't want the hierarchy. We just want the raw start of week field. And there we go. Now we can clearly see the weekly profit trend over time, all the way through April 2025. The pattern is much more insightful now. The formatting already looks clean, so I won't change the x-axis or y-axis labels. What I will do is turn on data labels and update the chart title to Weekly Profit. Now, this line chart shows profit by week, which is helpful. But we can add even more value without cluttering the chart. One great way to do that is by using tooltips, like we practiced earlier. Let's drag total sales and profit margin into the tooltips field. Now, when we hover over any week, we can see all three metrics: profit, sales, and margin. At the weekly level, without needing to display multiple lines on the same chart. And that's it. We've just built a clean and effective line chart. Now let's talk about area charts. I'll copy this line chart using copy and paste, and drag the duplicate below. This time, instead of profit, we'll visualize defective amount. So I'll remove total profit and drag in defective amount. First, let's update the title to Defective Amount by Year and Month. We will use red to represent defective metrics. I'll also adjust the data color to a shade of red to stay consistent with our theme. Now, let's change the visual type from a line chart to an area chart. When you're viewing a single data series, the only real difference between a line chart and an area chart is that the area under the line is filled. You can think of it as a line chart with shading underneath. In this case, switching to an area chart doesn't add much additional value. But area charts really shine when comparing multiple series. So let's add another metric, cancel quantity. I'll drag that into the y-axis as well. Now we have two overlapping area series. Some people prefer the default overlapping style, but personally, I like using a stacked area chart. This version stacks the series on top of each other instead of overlapping them. I'll switch the visual type to stacked area chart. Now there's no overlap, and we can clearly see both the overall trend and the composition. By tracking both top and bottom lines, we can easily see the total monthly volume of defective amount and cancel quantity over time. You'll notice that these two metrics follow a very similar trend. That makes sense. Higher defective amounts tend to lead to higher cancel quantities. The relationship is logical and easy to interpret visually. And that's the power of line and area charts. They help us uncover trends and relationships over time in a clear and intuitive way. Next, I want to explore a pane that we haven't touched yet, the third option here in the Visualizations panel, the Analytics pane. Now, this pane is only available for certain visual types. For many visuals, the Analytics options are quite limited. However, the line chart is one of the visualizations that offers very rich and robust analytics features. Let's take a look at a visualization of defective rate by order year and experiment with some of these tools. We'll start with the trend line. All we have to do is click Add, and Power BI automatically fits a line to our data series over time. This gives us a smoothed out view of the overall direction, helping us see where things are headed. In this case, I'm seeing a very encouraging trend. The defective rate has a clear downward slope over the past 5 years, which suggests improvement over time. Like everything else in Power BI, the look and feel is completely customizable. Right now, the default black line feels a bit overpowering. So I'm going to reduce the transparency to about 50% to make it more subtle. I'll also change the line style from solid to dashed. I think that looks cleaner in this case. The default settings work just fine otherwise. And that's our trend line, very simple to apply, but extremely powerful. We have similar options for constant, minimum, maximum, average, median, and percentile lines. All of these essentially add horizontal reference lines to the chart. For example, a constant line allows you to define a specific value, say 1% effective rate, and plot it as a benchmark. This is useful when you have fixed goals or targets. A minimum line identifies the lowest value in the selected time range. A maximum line shows the highest value. Together, min and max lines help us understand the range of variation over time. The average, median, and percentile lines work in a similar way. They provide statistical context, but in this case, adding too many reference lines might make the visual feel cluttered. Instead, I'd like to focus on one more powerful tool, the forecast option. This is where we can address an important question. How is the defective rate expected to behave over the next few years? Power BI makes forecasting very user-friendly. All we need to do is click Add Forecast. By default, it generates a forecast of 10 points. Since our axis is yearly, that means it's projecting 10 years into the future. Now, forecasting 10 years out is usually unreliable, and realistically, we would lose confidence in predictions that far ahead. I don't think our clients would appreciate that level of speculation either. So instead, let's narrow the forecast to the next 1 or 2 years. That gives us a more practical and credible outlook. You'll also see an option to ignore last points. If we know a specific year was an outlier or anomaly, we could exclude it from the model. For this example, we'll keep it at 0. Now let's talk about the confidence interval. This setting determines the probability that the true future values will fall within the shaded forecast range. Higher confidence, wider shaded range. Lower confidence, narrower shaded range. If I reduce it to 75% and apply, you'll see the band shrink significantly. That's because we're targeting a tighter range with lower confidence. Best practice is typically to use 90% or 95% confidence. For our purposes, we'll set it to 95%. There's also a seasonality option. If we know that certain months, like June or July, typically show seasonal dips, we can manually adjust that factor to improve the forecast model. And there we go, that's our forecast visualization. That wraps up today's lesson. We created line and area charts, used trend lines to identify long-term patterns, and applied forecasting to project effective rate over the next 2 years. In the next lesson, we'll explore pie charts, donut charts, and tree maps, and discuss when each one is most effective. Thanks so much for watching. If you found this helpful, don't forget to subscribe to the channel to support our work and stay up to date with future lessons. See you next time.